The evidence suggests that Leedskalnin's achievement involved not just moving massive stones but arranging them according to principles that researchers are still working to understand completely. These preservation efforts take on greater significance when considering how Leedskalnin's methods compare to construction techniques used at ancient sites worldwide, where similar engineering challenges produced remarkably parallel solutions across different cultures and time periods. Edward Leedskalnin's achievement becomes even more remarkable when compared to documented construction techniques from ancient civilizations that faced similar engineering challenges. Orville Irwin's detailed research reveals that Leedskalnin relied on simple mechanical principles rather than mysterious technologies, using tripods, blocks and tackles, and iron gears salvaged from a Ford Model A to accomplish his construction. These basic tools, combined with exceptional understanding of leverage and mechanical advantage, allowed him to manipulate massive stone blocks using methods that ancient builders would have recognized and understood. The tripod systems that Leedskalnin employed mirror techniques documented at megalithic sites worldwide, where builders used wooden frameworks to position massive stones with mathematical precision. Archaeological evidence from Sacsayhuamán in Peru shows that Incan builders used similar tripod arrangements to move granite blocks weighing hundreds of tons across mountainous terrain. The stone-cutting techniques evident at both sites demonstrate comparable understanding of how to shape hard materials using simple tools applied with extraordinary skill and patience. Leedskalnin's use of pulleys and block and tackle systems reflects mechanical principles that ancient Egyptian builders mastered during pyramid construction. Hieroglyphic records document the use of rope and pulley systems for moving limestone blocks, though the scale of operations required massive crews working in coordination. The mathematical relationships governing mechanical advantage remain constant across time periods, meaning that Leedskalnin's achievement required the same understanding of physics that ancient builders possessed, applied with remarkable individual efficiency. The iron gears from the Ford Model A that Leedskalnin incorporated into his construction equipment demonstrate how he adapted available materials to create specialized tools for stone manipulation. Ancient builders similarly repurposed available technologies, using bronze tools, wooden rollers, and rope systems to accomplish construction projects that modern engineers struggle to replicate. The creativity required to transform automotive components into stone-moving equipment parallels the ingenuity that ancient civilizations showed in developing construction techniques using materials and tools available during their respective eras. Modern experimental archaeology projects attempting to recreate ancient construction methods consistently validate the effectiveness of simple mechanical systems when applied with sufficient knowledge and skill. Teams using wooden rollers, copper tools, and rope systems have successfully moved multi-ton stone blocks, though these experiments require large crews working for extended periods to accomplish what individual ancient builders apparently achieved more efficiently. The gap between experimental results and historical achievements suggests that ancient builders possessed mechanical knowledge and techniques that modern reconstructions have not fully captured. Leedskalnin's published statements about discovering the secrets of the pyramids take on new significance when viewed alongside evidence of sophisticated mechanical engineering at ancient sites. His claim suggests familiarity with construction principles that pyramid builders used, rather than access to supernatural technologies. The mechanical advantage systems required for pyramid construction involved the same physics principles that Leedskalnin applied at Coral Castle, though implemented on vastly different scales using materials available during respective time periods. The precision evident in both ancient megalithic construction and Leedskalnin's work demonstrates mastery of surveying and measurement techniques that exceed typical expectations for their respective eras. Ancient builders achieved mathematical accuracy in stone placement that required sophisticated understanding of geometry and engineering principles. Leedskalnin's construction shows comparable precision in stone cutting and structural alignment, suggesting access to measurement and calculation methods that most builders of his era never possessed. Stone-cutting techniques documented at ancient sites reveal approaches to shaping hard materials that Leedskalnin appears to have understood and applied using available tools. Ancient builders developed methods for splitting granite and limestone using wedges, thermal expansion, and controlled fracturing that allowed them to shape massive blocks with remarkable precision. The tool marks visible on Coral Castle stones suggest similar techniques adapted for working with oolitic limestone using hand tools available during the 1930s. The mathematical relationships governing structural stability remain constant across time periods, meaning that both ancient builders and Leedskalnin had to understand the same engineering principles to achieve lasting construction. Ancient megalithic sites demonstrate sophisticated knowledge of load distribution, foundation engineering, and structural integration that prevented collapse over millennia. Coral Castle shows comparable understanding of these principles applied to create stable construction using mortarless stone assembly techniques. Leedskalnin's achievement represents a unique preservation of construction knowledge that connects modern times to ancient building traditions that mainstream archaeology has struggled to explain. His success in applying mechanical principles to accomplish seemingly impossible construction demonstrates that advanced building techniques depend on understanding natural forces rather than access to sophisticated equipment. The bridge he created between ancient wisdom and modern capabilities suggests that traditional construction knowledge remained accessible to individuals who approached engineering challenges with sufficient dedication and insight. The evidence positions his work as crucial documentation of construction techniques that ancient civilizations developed and applied on massive scales using similar mechanical principles. His preservation of these methods during the 20th century provides modern researchers with practical examples of how ancient builders might have accomplished their remarkable achievements. The consistency of engineering principles across different time periods and cultures suggests that effective construction techniques represent universal applications of physics rather than culture-specific innovations. These connections between ancient and modern construction methods raise fundamental questions about how such knowledge traveled across time and geography, creating patterns that researchers are only beginning to map and understand.